All right. A consumer has a current income of 60 kwacha, which can be spent only on goods X and Y. The price of good X is 3 kwacha and the price of good Y is 2 kwacha. Graph the consumer's budget constraint, clearly labeling the intercepts and the slope of the budget line. All right. So, as you can see, the consumer theory is all about consumers making decisions when purchasing goods so that we can have the most satisfaction or the most value from those goods. So, in this case, the first thing we need to do is we need to make our budget constraint line, which is in this format here: M equals PX times X plus PY times Y. So in this case, M represents income. So in this question here, the income is 60 kwacha. So let me just write it here. Yeah, so in this case here, the income is 60 kwacha. So we replace 60 with M with 60. So we write 60 here. They've told us the price of good X is 3 kwacha. So we replace PX with 3. We haven't been given the quantity, so you leave X like that. Plus, the price of good Y is 2 kwacha, so you place PY with 2. And we haven't been given the quantity of good Y. So this is our budget constraint line, right? So they want us to graph it, all right? They want us to graph this line. So we can draw the Y-axis here, and we can draw the X-axis here. So they also want us to label the intercepts. Okay, so if we can label the intercepts, we're going to get our full line. All right. Remember, an intercept is where a line cuts an axis. So if you see the y-intercept, it's where the line cuts or touches the y-axis. If you hear the x-intercept, it's where the line touches or crosses the x-axis. So in order to get our intercepts, it's easy, all right? If we want to get our x-intercept, you equate y to 0. You're going to say y is going to be 0. Because remember, along this, our x-intercept is going to be along this x-axis here. And any point along this x-axis, y is 0. Okay? Even the y-axis, any point along this y-axis, this vertical line here, x is 0. Okay? So we start with our x-intercept. We equate y to 0. So we come back to our budget constraint line. So we're going to say 60 equals 3x plus 2y. So y, you replace it with 0. 2 times 0, that is 0. So we have 60 equals 3x. Divide both sides by 3. get the value of x. So x equals 20. So what this is telling us is that if this consumer wants to only buy good X, they can only buy 20 units of good X. So along your X axis, you put 20 here. Okay. If you just want to only buy good X, you can only buy 20 units of good X. Any questions before I get the y-intercept? Mm-hmm. Yes, is that a question? Okay, don't worry, I'm recording. I'll post the moment it's done recording. Yeah, because I've noticed around this time, yes, network is bad. People are getting kicked in, kicked out. So, yes, if you're having network problems, colleagues, don't worry. The recording is there. And what I'll do is after I'm done solving on this, I'll send you the PDF file, which will have all these workings there. Okay, so we want to find our y-intercept. So to get your y-intercept, equate x to 0. So we come back to our budget constraint line. 60 equals 3. Then substitute x with 0 plus 2y. 3 times 0, that is 0. So we remain with 60 equals 2y. So in order to get the value of y, we divide both sides by 2. So y equals 60 divided by 2, that is 30. So if we only want to buy good y, then we can only buy 30 units of good y. So on your y-axis, you're going to plot this 30 here. And then you just connect the 2 points. All right? Connect the 2 points. Now, this is the shortcut method. If you want to get all the exact points here, what you can do is you make y the subject of the formula for this equation. All right. Once you make y the subject of the formula, you just start substituting. Say when x equals this number, y equals that. X equals this number, y equals that. Okay. Yes. I believe we all are able to make y the subject of the formula for this equation. Okay. Now they want us also to get the slope of the budget line. Remember the slope of the budget line, the opportunity cost of consuming one more good. To be specific, how many units of good Y you need to give up in order to obtain additional units of good X. So the slope, remember, just says slope equals negative px over py. Remember, px is 3, so you say negative 3 over py is 2, negative 3 over 2. Right? Negative 3 divided by 2, that is negative 1.5. So what this is telling us here, this 1.5 here, we ignore the negative sign. Negative is just representing this downward sloping line. So what is this telling us is, for us to get one more of good x, we need to give up 1.5 units of good y. Okay? To get one more unit of good x, you need to give up 1.5 units of good y. Okay, so here on the graph, you can write the slope as a fraction or as a decimal. In the form of a fraction, what it means, you have to give up 2 units of good y to get 3 units of good x. Okay, you have to give up 2 units of good y to get 3 units of good x. Then when you get this, it tells you in order to get one more unit of good x, you need to give up 1.5 units of good y. Okay, we got, oh, before, any questions? All right, suppose the consumer chooses to purchase 12 units of good X. On the same graph, show the consumer's utility maximizing bundle quantities of X and Y and the indifference curve through this point. So the utility maximizing bundle tells you the combination of good X and good Y that will give you the maximum utility, which is also the maximum satisfaction. So here, since we've already been given 12 units of good X, so if you obtain 12 units of good X, you have maximum satisfaction. But we need also to know how many units of good Y do you also need to have maximum satisfaction. Okay, then an indifference curve. Okay, an indifference curve, it's a line like this, a curved slope like this. It shows the combination of goods that you can get, but you have the same satisfaction, right? This indifference curve represents satisfaction, okay? And any point along this indifference curve is going to give you the same satisfaction, okay? So where this indifference curve and the budget line touch, that's the point of maximizing your utility. Okay, where the indifference curve and the budget line touch, that's where you find your maximizing bundle. So I'll teach you more about indifference curves, right? For now, that's what you have to know. Where it touches this budget constraint line, that point is going to give you your maximum utility or your maximum satisfaction. So we've already been given that 12 units of good X here, but we need to know how many units of good Y. So the way we get that, we're just going to substitute 12 for X in this equation and solve for Y. So our budget constraint equation is 60 equals 3, substitute X with 12, plus 2Y. 3 times 12, that is 36. We take this 36 over the equal sign so that we can put like terms together. So 60 minus 36 equals 2y. 60 minus 36, that is 24. We have 2y here. To get the value of y, we divide both sides by 2. So y equals 12. So the combination of good x and good y that gave us the most satisfaction is 12 units of good x and 12 units of good y. Okay, when we purchase 12 units of good x and we purchase 12 units of good y, we're going to get our maximum satisfaction. So we are done with the question. We've shown the intercepts, our y-intercept, x-intercept. We've shown our slope, -3/2, which is telling us we need to give up 2 units of good y to get 3 units of good x. We've shown the indifference curve. The indifference curve shows the combination of good x and y that you can have but maintain the same satisfaction. Okay? Because these indifference curves, they're all representing satisfaction. So any point along that curve is going to give you the same satisfaction. Right? We've drawn our budget constraint line, and the point of maximizing our utility is where the indifference curve and the budget line touch each other. Where they touch each other, that point is going to represent the quantities of good x and y that will give you the most satisfaction.